In this video, we're going to look at section 4.2 for Math 058, which is solving proportions. In order to solve a proportion, you're going to find the cross product like you did in 4.1, and for a proportion that needs solved, you're going to have one of the numbers missing being unknown, which will be represented by a variable. And so you would simplify one side of the equation, and then you're going to divide both sides of the equation by the coefficient of that variable and simplify. So this might not make sense to you right now, but we will look at several examples so that the steps will make sense by the end of the lesson. So the first step in solving proportions in a word problem is to actually set up the proportion. When setting up a proportion to solve for an unknown variable, there are multiple steps to choose from. Consider the situation where a baker is scaling a cookie recipe. The recipe uses 4 cups of flour and makes 36 cookies. The baker wants to determine how many cups of flour are needed to make 60 cookies. And so first, let's analyze the problem and see how we can use the information given to set up a proportion. So the unknown value in this is the flour needed for 60 cookies. And the units that we have the units of cups for our flours and cookies for our cookies. So one way to set up the proportion is to have the matching units in the numerators and matching units in the denominators, and the variable in the numerator. Your variable is your unknown number. In this form, it is important to have one ratio being the original quantity and the other ratio being the scaled quantity. For our baking problem, the proportion in this form would be 4 cups is to 36 cookies as x cups is to 60 cookies, or 4 cups over 36 cookies equals x cups over 60 cookies. So the original values in this equation, are they on the right side or the left side? So the original values would be the ones that actually comes from the recipe. And so the original values are on the left-hand side. And so therefore, the scaled values, or how we're changing that recipe, is going to be on the right side for this example. And so it's asking us how many cups of flour are needed to make the cookies. And so now that we have all the information that we have pulled together, we're going to look at our proportion here. And so just for the math part of it, I'm going to leave off those labels and put 4 over 36 equals x over 60. Now when I am doing proportions, I usually like to do the cross product that gives me the x on my left hand side and then the two that have the numbers across from each other on the right hand side. The 36 is across from the x, so we'll have 36 x, which means 36 times x. Anytime a number and a variable or a letter are next to each other without anything in between, it means multiplication. So 36x means 36 times x. And we have our 4 across from our 60. So we'll do 4 times 60. And again, I like to use parentheses so my x doesn't get confused with a variable versus multiplication. And so the way it stands is we can't do anything with the 36x, but we can simplify our 4 times 60. So that's our next step. We're going to do 36 times x equals 240. And so what we want to do is get x by itself. That's the goal. And whenever you're trying to get a variable by itself, you're undoing what's being done. We're peeling away what's being done to be uh, singling out the x. And so 36 times x, we need to get rid of a multiplication by the opposite, which would be a division. And so we'll get rid of this by dividing by 36. And so we'll do 240 divided by 36. And that is what we saw in our directions to divide both sides of the equation by the coefficient, which just means front number, of the variable. So we're dividing both sides by that 36. And 36 divided by 36 is 1. And so we're left with 1x on this side, and 1 is usually not written in front of x because we know if we see an x, there's only one of them. And then 240 divided by 36 will give us our answer. And it doesn't come out evenly, so let's write it as a mixed number. So we have 6 and 2/3 cups. If you type in your calculator 240 over your fraction bar 36, it will give you 6 and 2/3 cups. If you just did 240 divided by 36, your second and your probability button, your PRB, should have an F with a double arrow, and a D next to it means fraction decimal, so hitting that shift or that second button, and your PRB button should change your decimal into 6 and 2/3 for you. Because 2/3 as a decimal is 0.666 repeating, and we don't want to use repeating decimals. We want to change them into fractions. Another way to set up the problem is to take the reciprocal of both sides of the proportion. This will result in the variable being in the denominator. So the reciprocal means to take your numerator and your denominator and your fraction and to flip them around. So your reciprocal you can think of as a flipped fraction. And so instead of 4 cups over 36 cookies, we're going to have 36 cookies over 4 cups. And I'll just put CO for cookies and C for cups just to make writing it easier since I'm drawing with my mouse. And so then we would flip the other side as well, because again we want cookies both on top this time. So we'll have 60 cookies over our X, or X cups. And will this change the solution of the problem? Hopefully you know that it won't, because if you look at our problem, we still have the 36 times the x and the 4 times the 60. So 36x equals 240 still, and our x still equals 6 and 2/3. So I just kind of shortcut that a little bit since we've already done all the math to cover that. So it gives us the same solution even if we set it up to have our cookies on the numerator and the cups in the denominator. So it's just trying to show us that as long as we're consistent on how we set them up, we will get an answer that makes sense. And so another way that you can write it is to have your matching units as one fraction and your other units in your other fraction, but again you have to be consistent. And so if we look at this, it's asking us, are the original values, so the values that were in the recipe, in the numerator the top or in the denominator the bottom? And it would be the denominator. They are in the bottom. And so the scaled versions, or the doubling, tripling, whatever it would be to make it bigger, would be in the numerator. And in this case, we are multiplying the recipe, not quite doubling, because 4 times 2 would be 8, and we only are using 6 and 2/3. But we're still scaling it up. And even if we did it this way, are we going to get the same solution as long as we're consistent? So we have scaled cups over original cups equals scaled cookies over original cookies. And again, if you notice our cross multiplication, we have 36 across from the x as well. And so yes, we will still get the same solution even if we put the same units on the same fraction. And the other way that we can do this is take the reciprocal of the one we just did, number 4. So we could put 4 cups over x cookies equals 36, sorry, x cup, 4 cups over x cups equals 36 cookies over 60 cookies. So we can flip the way that they gave it to us. And again, it would give us the same solution. So just be consistent in the way you're setting them up. I always use the story problem to guide how I'm setting up the equation for my proportions. So we're going to look at nursing notation next and see how that's written using proportions. In nursing, the following notations are commonly used to set up and solve proportions when preparing medications for patients. And so we have a little bit of a symbol change. Instead of a fraction bar, here we have colon. And then notice on one we have the equal sign in the middle, and on the other one we have a double colon. We have 2 colons right next to each other. The values b and c are known as the means, and a and d are known as the extremes. In both notations, the a compared to b represents a ratio where a is the numerator and b is the denominator. And then c compared to d, c would be your numerator and d would be your denominator. And so we can see that the symbol here, that 2 colon, is the same as the equal sign, because it's in the same spot with the letters all being in their identical places. One way to read this is A is to B as C is to D. And so this example we would have here would say 10 milligrams is to 1 milliliter as 12 and a half, or 12.5. So let's say 12 and 5/10 to be specific. Milligrams is to 1 and 25 hundredths of milliliters. It doesn't like my milligrams. Ah, that's why I'm not spelling them right. So 10 milligrams is to 1 milliliter as 12 and 5/10 milligrams is to 1 and 25 hundredths milliliters. When you're solving proportions using your nursing notation, you can put it in your standard form. You can write it as 2 ratios or 2 fractions and cross multiply. Or you can multiply the means together and the extremes together, because remember, this would be numerator denominator for A, B, and C and D. So numerator multiplies to denominator when you cross multiply, and the outside would then be the other numerator denominator combination. And so that's why they're talking about the means together and the extremes together. The means were close to the equal sign or the double colon, and the extremes were the outside. So we need to verify that we get the same results. So first let's write it in fraction form. So 8/15 equals 12 over x. Cross multiplying, our 8 is across from our x, and that gives us the same value as the 15 times the 12, or the 12 times the 15. So next thing to do is simplify our right hand side, and 12 times 15 is 180. And our last step is to divide by that coefficient, so that 8. And so that takes care of the 8 on the left to leave us only an x. And we can divide to get 22.5 or 22.5. And when we look at multiplying with our colon, in the double colon in the middle, we're going to multiply, remember, the inner two together and the outer two together. So we're still going to get our 8 times x equals 15 times 12. And it would continue on the same math. We're not really needing to copy the exact same work, so we'll just verify it like that we get to that step for 8 times x is the same as 15 times 12. So next step is for you to work through some of these problems to see if you have any trouble with your solving proportions. And so you can pause it, work these through, and then when you're finished, check your work. Again, the answer key is under the Files tab in Canvas. And when you're ready, unpause it, and we'll look at some story problems together. A nurse is told that a patient's IV is to run at a rate of 75 milliliters per hour. So when I'm doing these problems for myself, I usually just like, oh, okay, there's my rate, so I'm going to go ahead and write it down before I even finish reading my problem. So we have 75 milliliters per 1 hour of time. So that's our unit rate because the denominator is 1. And then continuing on with the story problem, if the nurse uses a 250 milliliter bag, so milliliters in the top, so my 250 milliliters also needs to be in the top. How long, so that's our unknown, and we can use any variable we want. The standard variable that you'll see is x, but we could use h to represent hour or anything else that we would want to do. How long will it be until the nurse replaces it? And so solving our proportion, our 75 is across from our x, and I forgot my x there, and that's the same amount as 1 times 250. Well, we know anything times 1 is 2 itself, so we're going to put 250 here, not even write the times 1. That saves us from one step of simplifying. So we just need to divide both sides by 75. And so we see that x equals, and again it doesn't come out evenly, so we'll change it to a mixed number in 3 1/3 hours. And interpret our results. So the nurse will need to change the patient's IV bag in 3 1/3 hours, or 3 hours and 20 minutes, because 60 minutes divided by 3 would be 20 minutes. And so that's really part of the importance that they're focusing on with our quantitative reasoning, is just not taking a number and looking at a number as a number, such as 3 1/3, but looking at it in the context of a situation. And so in this case, it represents hours, and more specifically, the hours that it will take before the nurse needs to change an IV bag again. So not just looking at the numbers, but looking at the whole picture of the problem. Our next problem switches career fields, and we're looking at a civil engineer who is making a scale model of a water pump to test before building the full-size version. 1 inch on the model represents 10 inches in the actual water pump. And so again, I can tell that they're giving me a ratio. And so I have 1 inch is being compared to 10 inches. Now notice I have both of these numbers in inches. And so I like to make sure that I am clear on what is what. So it says a 1 inch is the model, and that represents 10 inches on the actual water pump. So I'll put pump down here. So that way, when I'm given the next piece of information, I can tell based on my labels over here whether it will go on the top and the bottom, since inches and inches match. So that doesn't give me the clue that I need to know what place in the fraction the number will be put. And so if we continue, if the full-size water pump is designed to be 82 inches long, so that is the pump, so it will go in the denominator. How long will this length of the scale model be? So I'm going to just put an L up here for length. And so my 10 is across from my unknown, so we'll have 10 times our L. And again, we have a multiplication of 1, so I'm just going to put 1 times 82 is 82. And then we can divide our 10 off to get our length L by its side. And so the L that we have is 8.2. But again, it's not just 8.2, it's 8.2 inches. And clarifying it further for interpreting, we have that the length of the scale model for the water pump is 8.2 inches. Our next story problem deals with statistics. In the United States, 1 new person is infected with HIV every 10.5 minutes. How long will it take for 50 new people to become infected with HIV? So again, our first ratio that they give us is that 1 person in every 10.5 minutes. And so let's put 1 person over 10.5 or 10.5. It's easier to write it as a decimal in my mind. And that's in minutes. So how long? So that's going to be our unknown. So let's use M for minutes. Will it take for 50 people to become infected? Our 1 is with our M, and that is the same as 10.5 times 50. And we've mentioned before, 1 is not necessary. If I have an M, we know that there's 1. And then when we multiply 10.5 times 50, we get 525. And again, that represents minutes. And so our results are that it will take 525 minutes for 50 new people to become infected with HIV in the United States. Okay, we have 2 more story problems to go for examples. A certain type of chainsaw runs on a mixture of 128 ounces of gasoline for every 4 ounces of oil. If you want to use 5 ounces of oil to make the fuel mixture, how many ounces of gasoline are required? And so we need to make sure we set up our proportion. Again, let's reread and stop where we find our first part of the information. A certain type of chainsaw runs a mixture of 128 ounces of gas for every 4 ounces of oil. So 128 ounces, and that's gas, and it's 4 ounces of oil. And then we want to use 5 ounces of oil. We have oil in the denominator, so 5 ounces of oil will go in the denominator again. How many ounces of gasoline, let's use G to represent our gasoline, are required? Our 4 is across from our G, and that's the same as 5 times 128. And so for G, when we multiply 5 times 128, we get 640. And we'll need to divide both sides by 4 to be able to get the variable G by itself. And that equals 160. But again, it's not just 160, it's 160 ounces, and specifically, it's 160 ounces of gas. So interpreting our results in the context of our story problem says that it will take 160 gallons of gas to mix with 5 ounces of, oh, why did I say gallons? Whew, that would be a lot. Sorry, ounces to mix with 5 ounces of oil. And our last story problem says that a machinist runs a machine that can make 6 parts for every 5 minutes. So our proportion, 6 parts over 5 minutes. How long will it take? So that's in minutes. So that's going to go on the bottom. Let's use X this time to make 100 parts. Notice it says to round your answer to the nearest tenth. So we're not going to get something that divides evenly. And it wants us to round 1 decimal place. And so solving the proportion, we get our 6 times our X and 5 times 100, which I'm just going to do in my head to get 500, and dividing by 6 gives us X on the left and approximately 83.3, and that is in minutes. And so again, interpreting our results says that it will take approximately, and I say approximately because we rounded it just a tad, minutes for a machine is to make our 100 parts. So there's your lesson 4.2 in solving proportions. If you have any questions while you're working through your Hawks homework, make sure you screenshot it and send me an email. Go to the tutor or whatever you need to do to get help, and I'll see you next time.